Welcome back. In this lecture, we will cover piecewise functions. If you've ever worked with the absolute value, then you've already worked with a piecewise function. As you hopefully read, a piecewise function is one that is defined by more than one rule, where each rule is defined on a different part of the overall domain. Let's see how the absolute value function fits this description. Most people would describe absolute value in geometric terms as distance of a number from zero. Algebraically, however, the absolute value function is defined piecewise. This means that it isn't defined by a single rule. But wait, you might say, isn't the absolute value written as f of x equals absolute value x with bars? That's a single equation. The problem is that this is just notation. It is a special naming of the absolute value function. But one could rightly ask, how is this notation defined? The notation by itself doesn't actually reveal what happens to x in terms of algebraic operations. Let's see if we can work it out. Let's start with some examples. First, suppose we pick a positive number, like x equals 3. Then we know that the absolute value of 3 just equals 3. If we pick a different positive number, like x equals 15, then we find that the absolute value of 15 is 15. With a little thought, we realize that whenever x is greater than or equal to 0, we will just have the absolute value of x is equal to x. We've just established a first rule for the absolute value, namely, if x is greater than or equal to 0, then the absolute value of x just equals x. In other words, one piece of the absolute value function is the function f1 of x equals x on the interval from 0 to infinity. So what happens when we pick a negative number? Again, let's start with an example. Suppose we choose x equals, say, negative 3. Then the absolute value of negative 3 is 3. In this case, we notice that the input and the corresponding output are opposites of one another. So we could say for x less than 0, the absolute value of x equals the opposite of x. This is our second rule, meaning that the other piece of the absolute value function is the function f2 of x equals opposite x for negative infinity to 0. So if we put the whole thing together, it looks like this. Notice that the domain of the absolute value function is all real numbers, which is just the union of the domains of those individual functions we mentioned above. Now the varieties of piecewise functions are actually infinite, but some, like the absolute value function, are special in that they are both common and pretty important. One simple yet very important piecewise function is what's called the Heaviside step function. It has many applications in modeling of physical systems. It is defined as follows. H of t equals 0 if t is less than 0, and 1 if t is greater than 0. T here is usually used instead of x because in modeling physical systems, time is often involved, so t usually represents something like time. Now, depending on the context, there are some different definitions of the Heaviside function. For instance, you might see the Heaviside function defined as 0 if t is less than 0, and 1/2 if t equals 0, and then 1 if t is greater than 0. It all depends on the context. We'll play around with the Heaviside function and see its usages after we discuss a little bit more about functions in general, so keep that in the back of your mind. Let's end this short lecture by looking at two final piecewise functions that require an infinite number of rules. These are the floor and ceiling functions. Like the absolute value function, they also have some special notation. The floor function is often denoted by this, while the ceiling function is usually denoted by this. The floor function is also called the greatest integer function and is defined in words to be the largest integer less than or equal to the input x. In its piecewise format, this would look like the following. Notice that the domain is actually all real numbers, but the outputs are only integers. The ceiling function is defined similarly, but it's the smallest integer that is greater than or equal to the input x. See if you can describe its piecewise format. Then look it up by Googling it and see if you got it right. So that's it for this short little lecture. Those are piecewise functions. If you have any questions, go to the discussion page and ask them there. In the next lecture, we'll start looking at graphing. See you there.